Hello everyone, I'm Megshi Thakur and today I will walk you through my research on explainable AI in clinical decision support system. Today we will cover the motivation, research question, current work using Sharp and Lime, and some questions in this exciting space. So let me ask you one question. Would you trust an AI model that said a patient is high risk, but it couldn't tell you why? Me neither. In healthcare, we don't just need answers, we need justifications, and that's the gap explainable AI tries to fill in. So clinical decision making is high stake and the wrong decision can cost life. That's where explainable AI becomes critical and it bridges the gap between AI's accuracy and the transparency that clinicians need. Moving on to the research questions. So I went into this research with a very clear question. How can techniques like Sharp and Lime, which explain AI decisions, actually help clinicians trust these predictions? We are not just trying to make the AI smarter, we are just trying to make it understandable. And that's important for both regulatory and compliance and ethical deployment of AI in healthcare. That's what I believe. Moving on to the literature review summary. So already a lot of work has been done for transformers like Clinical, Word, and these are great at processing medical notes. Sharp and Lime are two of the most important, I think, and most popular explainability tool. But what about the gap? Most of these tools weren't built with clinicians in mind. So even if the model gets it right, the explanation might not be as useful. However, these challenges, many explanations which are not aligning on how clinician thinks, and there are still some tools which are rarely evaluated in real world settings. And then in the past projects and paper, people focused a lot on these models' performances, but they did not focus too much on the why. So that's why what my work tries to change, that by making these explanations feel like clinical reasoning, not just an output from a code. And much of these existing work, they focus on deploying these powerful models. But the explanation quality, user interface design, and real clinical evaluations are still lacking. As I said, that's what the gap my research seeks to address. Not just the accurate prediction, but explainable ones where clinician can act on. Moving on to the proposed methodologies. So here's how I approach it. I built a data set of diseases, symptoms, and associated risk levels, low, moderate, or high. I fine-tuned clinical BERT, a model which is trained on medical text to classify the risk. Then I wrapped the model with Sharp and Lime to explain what each word, like headache or fever, actually does to the prediction. We use Sharp, which is usually used in so many existing models to visualize global and token level features, importance, and Lime to explain individual predictions. So moving on to the next slide here, which is the expected result. And see what we find. Sharp worked really well. It showed that symptoms like fatigue and headache pushed the model towards moderate risk. Others, like fever, sometimes pull the prediction down. So now instead of just seeing moderate risk, we can directly see here why. So what our model did here is it correctly classified risk levels and achieved meaningful distinctions between low, moderate, and high patients. Sharp revealed symptoms like persistent cough and headache. These are the top contributors to the moderate risk case. And then the sharp bar chart, it helps us trace the prediction back to the exact token for which, for example, in one case, fever reduced the confidence in moderate risk while headache increased it. That's what our bar chart here shows. If you look very carefully, the sharp value for fever is negative 0, negative 0.023, but for the symptom headache, the sharp value is positive, which means that it pushed the model towards saying that the patient is moderate risk. Moving on to the next slide. So here's an example. You can literally see which symptoms the model focus on. Headache in blue, and meaning it boosts the prediction. This chart shows how each symptom influences a moderate risk prediction. You can see headache has a positive sharp value, while fever has a negative one, meaning the model weighs differently. And this kind of token level insight builds the transparency and trust. For a patient reporting symptoms include fever and headache, sharp analyzers reveal that the fever positively influenced the model. This insight supports the model is not treating all the symptoms equally. It relies on specific pattern which it has learned from the data that we have provided. And moving on to the next slide here, which is a disease versus risk category. So diseases like pneumonia were mostly labeled moderate. Anemia showed up a lot high risk. That's the data distribution actually affect how the model thinks. So this chart just help us analyze that internally. This visualization show how different diseases were labeled by risk in the dataset. This impacts how model learns and the understanding that the data distribution help in interpreting models' behavior. So of course we are not done yet. There are still some big questions. How do we measure explanation quality? What's the best way to show this to clinicians without overwhelming them? And how do we extend this beyond text? So we want to extend this not just to interpret text, but also to interpret labs, images, etc. These are future directions my work will continue to explore in. Moving on to the reference here. So finally, just a nod to an amazing researchers who have already built the tools I work with, Sharp, Lime, Clinical Bird, and the academic work that laid the foundation. And just for closing, I would say thank you so much for your time. I'm happy to take any questions or any feedback that you have in the comments down below. So thank you.